Hey guys, we're going to be looking at a cipher called Vigenere today. This was actually used around the same time as Mary Queen of Scots, but as you can see already, just opening up the link for this widget, it has this big chart. It's got plain text here, so original text, and we've got a secret key. We've got all of these buttons to control the encryption and decryption. So I wanted to walk you through an example of how to encrypt text using the cipher, as well as how to decrypt text. To start off here, I'm just going to keep the original text message that they had as well as the secret key. So we are going to use the secret key in order to hide this message. So let's see here. First of all, I'm going to drag this slider here all the way down to slow. And we can use this to help us show how the message is being encrypted. So I'm actually going to restart it. And I'm just going to do one or two letters to show you how this is taking the key in the plain text and turning it into our ciphertext. Okay, I'm just going to pause it there for now. You'll notice here, if you look at the bottom, it's got the key in the plain text, and it's highlighting what's going on in colors that match up to the chart. So the key is currently on the second character, our plain text on the second character as well. And in the key, we've got that blue Y. As you can see, that's being highlighted on the vertical part of this chart, the vertical column here. There's our Y. And in the plain text, it's matched up with an F, which we find on the horizontal alphabet up at the top. So to find out what the encrypted letter is going to be for this pairing, we have to see where they meet up in the chart. So with this pairing, it matches up to a C, and so that is the ciphertext that is produced. I'm going to do one more. I'm going to skip over the spaces, and then we'll take a look at one more. Okay, here we are. Oops, pause it. This time we're on the C in the key, so that's on the vertical alphabet. We were on the L in the plain text, that is on the horizontal alphabet, and they meet up at an N. So that is what is produced in the ciphertext. I'm going to now let this get to the end of the key so we can see what happens when we run out of letters in the key. It is not as long as the plain text, so something has to happen in order to encode this whole message. Okay. So we saw it got to the end, and then it just cycled right back to the beginning, and it will continue going one by one in the key and in the plain text until we get to the end of the plain text. Look at maybe one more here. So I just let it go through one other. We can see we moved on to the next letter of the key, the next letter of the plain text. Those met up at a B. So I'm going to speed this up a bit and let it finish. And as you can see, it just keeps looping back through that key as much as it needs to in order to finish it. And now it's done. We've got some ciphertext here. So upon first glance, this probably just looks like a normal substitution cipher, maybe random substitution, maybe a Caesar shift. And if that were the case, then every I, for example, would be represented by the same letter in the ciphertext, because with a substitution cipher, every letter has another symbol or letter that always represents it. But let's look what happened here. With the first character, I, that's represented by a U. And I believe this is the 11th character here with this I. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this I is the 11th character. If this was substitution, then it should also be represented by a U. But let's count 11 in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I didn't mess up, that is being represented by this S. So that adds much more complexity to the decryption process if you are given this, and you can't even rely on the idea that an I will always be represented by the same letter. And this is because of that key. Depending on what character you're on in the key, it's producing a different letter, which makes this very, very difficult to decrypt if you don't have a tool like this. Now you will not have to worry about decrypting something like this on your own. However, this widget can also decrypt a message. So what I'm going to do is just copy the ciphertext that was produced. I'm going to use Control C to copy it. I'm going to get rid of this original text message. I'm going to paste the ciphertext that we produced. I'm keeping the same secret key, and I'm going to click Decrypt. Now, I'm going to slow this down again so we can see what happens. It'll be the same process. Let it pause real quick. You can already see in the plain text that it's producing, we're still using the same process. The key is on the vertical axis, if we want to call it that, or the vertical alphabet. The ciphertext now, or our text that we're working with, is on the horizontal, and we're just finding where they meet up. So this works backwards as well, as long as you have the same key. You can see here as I let this continue on, it's producing that original message using the decrypt feature. Now that we've seen this happen with the default example, try out some different text, maybe the same text with a different key, and you should find that this produces an encrypted piece of ciphertext that is very difficult to figure out, and that's what makes it so much stronger than something like Caesar cipher or random substitution.